Hi guys, today we're going to look at a problem. Reverse a stack, put this into the same stack. You can use a temp variable and a stack. This is a clue or a condition that has been provided in the part of the problem. So for that, let's take a problem. Like if this is a stack, 4, 3, 2, 1 is a stack. So what is the output should be is like 1, 2, 3, 4, and it should be on the same stack. So how do we do that? Take that as a clue, whatever they have provided the condition. So we can use a temp variable. I'm using a temp variable and I'm using another stack to bring it in this condition. So how I'm going to do is that. So first the stack will be like 4, 3, 2, 1. Push the element of 4 into a temp variable and keep the remaining elements 3, 2, 1 in the stack. And um, and then push all the elements of 3 to 1 into another stack. So it has been pushed to in this order. And once it is pushed, uh, take this temp variable into the stack A and the remaining elements of stack B to the stack A. So at this end of the first operation, so we're going to have an empty stack B and stack A where the first element is corrected or the last element which is corrected, and the remaining elements we have to work on. So go to this operation 2. So now the last element, this is the last in first out operation. So the last element that we can pop is 3. We have popped to temp variable, and the remaining elements 2 and 1 we pop to stack B. Once it is popped, we know this is the right element. The temp holds the right elements. So push this 3 to the stack A and the remaining elements 2 and 1 and make it empty. Why we are doing it like from stack A, stack B is that because we don't want to create multiple stack here. We wanted to just empty this, like use minimal stack space complexity, and like you always move from stack B and then again you return it back. Okay, when at the end of operation 3, let's see, we have now the temp variable will be 2, which is pushed, and we have like 4, 3, which is correct in correct order, and the remaining elements will go to the stack B. So we know this is the right element. So push the right element into stack A, 4, 3, 2, 1, which is the right order, and we have 1 in stack B. So push it back to the stack A. So this is the output of that we are looking for. So we got the one what is expected. So let's come to the coding. I just already written a coding to reduce the timing. So I have a stack B, created an object of created, like I used a new stack B. The length of this is the size of this stack A, and I have a method. So I'm going to do it in a recursive call. So every operation, this is the first set of operations. It will be called. So once this is all operation is completed, it will call the reverse stack again, and it will do the same operation. If you see, it is all same set of activities that we are doing it, and it is in 1, 2, 3 iterative way. So to execute that, I'm calling this reverse stack in recursive function, and this is an exit condition. If you see, is length is greater than lesser than 2, so I'm going to exit this condition. As I said, I'm going to have a temp variable. The first element of the stack A will be popped to temp variable, and the remaining of the stack A, I'm going to push it to stack B, and then at the end of this A, so push the element. This is at the end of the for loop. I'm going to end the for loop here, and then A dot push of temp. Push the temp variable, which is the correct element here, and the remaining elements, whatever we pushed to stack B, put it back into stack A, put back all the elements into stack A, and reduce the length. Why we are reducing the length? It's because we don't want to clear every element, right? We know the one element which is pushed, temp variable that we pushed, is the right element. So we are reducing the length so that it will start from the second element. So reverse stack and return B. So in the second operation, the length has reduced 1. So now it will start only from here, the 3 elements, and it will do the same operation. I hope it's easy to understand. Thank you guys.